Welcome back. So let's talk about two additional climate controls. We already talked about latitude and elevation. Latitude is the main driver of the climate. Elevation is pretty good too. But all six of these that we'll talk about in this section go into shaping climate. That's why studying weather and climate is so very complicated. There's all these factors you have to consider. So the two that we'll talk about this video are ocean currents and wind and weather patterns. So ocean currents, let's chat. So here's a map that shows the ocean surface temperatures. Red is warm, blues and purples are cold. So around the equator, we'd expect to find the warmest waters. We do. And the further you away, the colder the water gets. But it's not quite uniform. You see how some of this red kind of creeps up on the east coast? Whereas some of this blue kind of creeps down the west coast. Kind of the same here, how the kind of yellow and even some of the green makes its way up Africa. Some of the red creeps down the other side of Africa. So different surface currents can affect the climate. So as the ocean circulates, it has patterns in which it does. Here's a map that shows all these surface currents, how the water around the ocean kind of flows. Now we spent some time in one of the other geology classes that I teach, Geology 101, going into this, why that's the case, why currents are different, why are they going the way they're going. It's not necessary here, but if you're interested, that does get discussed in Geology 101. So again, typically around the equator, warm ocean currents. But, for example, we have kind of these red warm ocean currents going up, as an example, the east coast of the U.S. As it gets further away from the equator, it cools down, kind of comes back down as a blue cold ocean current, and it kind of cycles again. Same thing over here. We have kind of this warm ocean current going up Asia, cools down, comes down the west coast, warms up again, and we have these all around the world. But you can see, in general, for the most part, on either side of a continent, typically you'll have kind of warm ocean currents and cold ocean currents. Same thing in North America. We got warm ocean currents on the east, cold ocean currents on the west. This is why, if you've ever jumped in the water in California, if you've ever gone to San Diego, and you're like, yeah, just jump in the ocean, it's cold. You get this cold ocean current coming down from the north. Whereas if you ever go to the east coast and jump in the water, in the ocean, oh, it's nice, it's lovely, it's gorgeous. It's because you have this warm ocean current coming up. But dependent on the current just offshore, that can affect the climate. The temperature of the water offshore influences the temperature of coastal locations. So it doesn't affect, all the way inland, hundreds and thousands of miles, but, in general areas just on the coast or coastal locations. And these ocean currents also have a big effect if the winds are coming off the sea, off the ocean, blowing over these currents and then onto land. Sea surface temperature influences air temperature as well, because the surface of the ocean exchanges heat with the overlying atmosphere, so that can also affect weather and climate patterns. It also influences evaporation rates, which are generally higher where sea surface temperature is higher. So warmer ocean currents, more of that water is evaporating, going into the atmosphere, making clouds, making rain. So let's look at a couple locations. So here's South America. We have over here on the east coast versus location on the west coast. And just to remind you, on the east coast we have the warm Brazilian current coming down from the equator, but on the west coast we have the cold Peru current coming up from Antarctica. So on one side we have a cold ocean current, the other side warm ocean current. But if you look, that's very similar in a lot of different continents: Africa, North America, etc. So Peru, that one was on the west. Brazil, that one's on the east. Remember, this was the warm ocean current, so the temperatures are generally a little bit warmer, more precipitation. The warmer the water is, that means the more evaporation will occur, so therefore water's evaporating into the sky, more rain. Whereas on the west coast, a little bit cooler temperatures because it's next to a cold ocean current, and also much less precipitation. Much less precipitation. Let's go back here. Right? So latitude is a little bit different, but not so much that it should have such a great influence. So again, warmer ocean currents, higher temperatures, more precipitation. Colder ocean currents for coastal locations, colder temperatures, less precipitation. Colder air holds less moisture. Warmer air holds more moisture. That's why rainforests, in places that are hot and muggy, they're hot, and the hot air, just the sheer thermodynamics and physics of it, it has the ability to hold more moisture, therefore more humidity, more rain, etc. So, being near a warm or cold ocean current can affect the climate. What about different wind systems or wind patterns or weather patterns? So typically, weather moves in one direction, depending on where you're at. So in the U.S. and Arizona, we're kind of right in this location here. For the most part, on average, not always, not every day, but remember, weather changes daily. Weather includes sun, wind patterns, so the wind can change directions daily. But overall, in general, the wind goes from west to east. So if it's raining in California, a day later it'll be raining in Arizona. A day later it might be raining in Texas, going from west to east in general. Now, different weather, sometimes wind blows from different directions. That does occur, but in general, in the U.S., weather goes from west to east. If there's a storm on the west coast, it makes its way over to the east in a few days, however long that takes, generally. However, different parts of the world actually have general wind patterns in different directions. Kind of from central Mexico south through Central America and northern South America. In fact, the weather goes the other way. The weather goes from east to west. So, yeah, same thing with kind of up in northern reaches of Canada. The wind patterns and weather patterns generally go from east to west. That has to deal with some physics. That has to deal with the Earth's rotation. It has to deal with hot air rising, just like a hot air balloon. Hot air rises, cold air sinks. We'll talk about that here in just a second. But in general, this is kind of the general wind patterns that we see. So depending on which direction the wind blowing, is it blowing over a current? Is there other things, topography, mountains, some things we'll talk about in the next video, all of that plays a part. So, when we're looking at the Earth, because of what we see, so this is just kind of a cross-section of the Earth. So let's talk about what we see on the left. These patterns, which I'm about to discuss, repeat themselves whether I go north or south. So since we're in the northern hemisphere, we'll just kind of take a look at this northern hemisphere, and that's what this blow-up is here, all right? So we'll just kind of focus here. But again, the same patterns it's the same pattern in the southern hemisphere, south of the equator. So again, the equator receives the most solar energy, so it's going to be the warmest. So warm air, what does it do? It rises. Think of a hot air balloon. Hot air balloon, hot air rises. Therefore, cold air sinks. So if the area around the equator is going to be the warmest, then that warm air is rising. All right, so you got some warm air rising. As it begins to rise, it cools down. So as it's moving upwards, there's more air coming from below, and it kind of pushes it off north or south. Let's just, again, kind of follow this trend north in the northern hemisphere. So as this warm air rises, it cools down, and what does it begin to do? Sinks. Hot air rises, now it's cold, cold air sinks. Warm air rises, cold air sinks. So around the equator, the climates are going to have about, again, a constant temperature, no fluctuations in temperature range for the most part, but abundant precipitation in all seasons due to what we have going on here. Well, up at the poles, you get the least amount of solar energy, so the air is cold, right? What does cold air do? It doesn't want to rise in this area. It wants to stay low. It wants to sink. So it's kind of coming down this way. And as that begins to head further south, it warms up. So as it warms up, it rises, cools down, and so we get this opposite pattern. This kind of what do you call this? This cell, this circular nature of air going up when it's warm, going down when it's cold. And then you got whatever's going on in the middle here. So again, so we have warm air rising and cold air sinking. Warm air rising, cold air sinking. Warm air rising, cold air sinking. And as this cold air is sinking, it kind of peels off in two directions. So now it's warm. So as it's warming up, now it wants to go back up. As it's warming up, it wants to go back up. Now this middle cell is encountering this polar cell, and it's doing what it does here. Now, because of all of this, because of what's going on here, you get all these different precipitations happening. For example, when warm air rises and cools down, it produces a lot of rain, so a bunch of precipitation. When cold air descends, cold air can hold less moisture. So when cold air is descending over an area and it begins to warm up, it's very dry air. So any area kind of around 30 degrees north latitude, that's going to be very dry. That's where we are. That's where Phoenix is. You go a little bit further up, ample precipitation, because again, you get some warm air rising in this case, and then cold air descending, sparse precipitation, very dry. Just because it's cold doesn't mean, you know, there's a lot of precipitation. Again, that's a very quick summary of something very complicated. I go into more on that in Geology 101. So again, when we're looking at wind systems and pressure systems, the Earth's average pressure and wind patterns influence climate by moving heat and moisture. So hot air rises, cold air sinks. It causes areas of low and high pressure, influencing the tracks of storms. These patterns shift with seasons because of differential heating of the continents, and the reason we have seasons is because the Earth is tilted. Again, more on that in another class if that interests you. So here we're just talking about what influences climate. So let's see. So again, looking at around the equator, again, warm temperatures, little fluctuation, and it says here abundant precipitation in all seasons. Yep, we see that. What about just a little bit north, so about 15 degrees north or south latitude? It says wet summers, dry winters. So a little bit more temperature range. Remember, the further you get from the equator, latitude, you get more of a temperature range. Difference between highs and lows. So let's see. Wet summer, yep. Dry winter, yep. What about in the subtropical high? So it's called, these are pressure systems, highs and lows. It's called low when the air is rising because it's kind of pulling air off the surface, taking that pressure away from the surface. And it's called a high when the air is descending and coming back onto the surface. That air is pushing down onto the surface, so it's a higher pressure. Air is pushing down onto the surface. So in this third area, again, a bigger range. Here's Phoenix, around 33.5 degrees north, so kind of in this subtropical high. It says dry in all seasons. Yep, yes it sure is. A little bit further north, kind of just above the subtropical high. Wet winters, and dry summers. This is what we see in Seattle. A little bit bigger range because we're getting further from the from 0 degrees latitude from the equator. In the next one, the subpolar low, so it's low pressure because air is rising away from the surface, relieving the pressure. So we should see a bigger temperature range and ample precipitation. So bigger temperature range, decent, not a lot, but decent precipitation throughout the year. England. What about up in the polar high? High pressure because cold air is descending, pushing back down, applying pressure to the Earth. Sparse precipitation in all seasons. Bigger temperature range. Now we're looking all the way up in Alaska. Very complicated. This is a very quick, somewhat simplified and generalized look at how wind patterns, weather patterns influence climate. All this is due to Earth's rotation. Something called the Coriolis effect is at play there. Again, it gets a little complicated for what we needed here, but just know that these general weather patterns and wind patterns exist, and they also help to drive our climate. As an example, Phoenix is right in this, what's called the subtropical high. We have cold, dry air warming up, descending down onto our area. It's very dry, pushes out all the clouds. That's why it's always sunny. That's why it's always so dry. All right, so we'll pause there. When we come back, we'll talk about the last two climate controls. We'll see you back here in just a second.